So our lesson today is on molar conversions. We now know that a mole is 6.02 times 10 to the 23rd particles. We also know that the molar mass is our decimal number from the periodic table, how many grams are in every mole of a substance. We have practiced calculating the molar mass for either an element or a compound, and we're going to be using all of this stuff today to do something called molar conversions. The slide part of this lecture video is going to be very short, very brief, but most of our lesson today is going to be practicing solving conversion problems, which are dimensional analysis, which yes, we will review how to do. But since it's all calculation stuff for us today, yes, you need your calculator in addition to your periodic table and all of that fun stuff. So let's get started. Okay, molar conversions, and there's my cute little mole. As cute as he is, you guys, y'all, in chemistry, a mole is not a furry animal. A mole is not a yucky growth on your skin. A mole is a unit. 1 mole is 6.02 times 10 to the 23rd particles. So reviewing the mole. A mole can tell you how many of something you have. A mole is 6.02 times 10 to the 23rd particles. Keep in mind, particles, I can substitute that word for either atoms, ions, molecules, or formula units. Those are the big 4 in chemistry of what a particle is. And notice I wrote F.U. FU is the literal abbreviation for formula units in chemistry. I do not make the rules, so enjoy getting to write FU on a chemistry page. All right, but the key thing here is that we know that a mole is equal to this amount of particles. Y'all, that is an equality. An equality I can actually use as a conversion factor where I put 1/2 of that equality on the top of a fraction and 1/2 on the bottom. So here I have written this understanding as an equality. There's 6.02 times 10 to the 23rd particles in every 1 mole. Those two things are equivalent, okay? Or I could flip them to where I could write the mole on top. 1 mole is equal to 6.02 times 10 to the 23rd particles. Now, if you'll remember conversion factors, we can actually utilize these mathematically to convert back and forth between particles and moles. And we will practice doing that here in a little bit. So yeah, a mole is that number, that famous number called Avogadro's number. So here's a fun question. Which has more atoms? A mole of aluminum or a mole of hydrogen? Y'all, trick question. They both have the exact same number of atoms. Both are going to have 6.02 times 10 to the 23rd atoms. Okay, that's a mole. That is just what it is. But there is something that will be different depending on whether you're hydrogen, who's the smallest element on the periodic table, and aluminum. So what would be different? Their masses, which this brings us into the concept of molar mass. If I were to ask you guys to find the molar mass of potassium sulfide, in fact, I'm going to get my periodic table out here right now, and we are going to utilize him. So finding the molar mass of potassium sulfide, you were ready to go. You were like, yay, I'm going to obviously need some potassium up first, but then you were getting stuck immediately because we cannot do nothing with molar mass if we don't know what the formula is for potassium sulfide. So let's write that out. Potassium sulfide, K2S. I get that subscript of a 2 because sulfur, coming from the sulfide part of that chemical formula, has a -2. Potassium has a +1, so the formula or the ratio of those ions to each other to be neutral is 2 positively 1 charged potassiums to every 1 negatively 2 charged sulfurs. Anyway, so that's potassium sulfide. Amazing. We love this. So now I got to count some things. Potassium, his molar mass is 39.10. Yes, and so that's what I'm showing here in this part of the mathematical calculation. I multiply that by 2 because there are 2 of him. The next element in my formula is sulfur. Sulfur's molar mass is 32.07, and I only have 1 of him, so I do not have to multiply that 32.07 times anything. But that does give me the molar mass total for potassium sulfide is 110.27 grams per mole. Okay, so that means that if I have a mole of potassium sulfide, it's going to weigh 110.27 grams, okay? So that's nothing new, nothing super duper scary. We've been able to calculate the molar mass. But let's move on with this. So now we know a mole can not only tell you that there are 6.02 times 10 to the 23rd things of that thing, it can also tell you the mass of a mole or the molar mass on my periodic table. So that molar mass that we calculated for potassium sulfide, that 110.27, I can write that as a conversion factor. That 102.27, we knew that the units were grams per mole, or in other words, grams for every 1 mole. You guys, that is also inequality. So I can express the molar mass as a conversion factor. I can write the 110.27 grams on top and the mole on bottom, or I can flippity-floppity the other way, depending on whether I'm converting from grams to moles or moles to grams. Y'all are like, she's speaking a different language. Trust and believe. We will work these practice examples and you'll see a little bit more what I'm talking about. So this brings us to our mole map. Using the concept of Avogadro's number, if you'll notice, these two conversion factors over here show and remind me that 1 mole is equal to 6.02 times 10 to the 23rd particles. Here I've written that exact same conversion factor, just flipped the other direction. Now the reason why I wrote the two versions of that conversion factor is because if I'm following the arrow wanting to convert from moles to a number of particles, I would write the conversion factor oriented this way. Okay, it's going to be oriented this way because we will show how the units cancel off to get us there. Trust and believe we will do this. But if I'm going in the opposite direction, meaning going from particles to moles, the conversion factor needs to be flipped, okay? So navigating between moles and particles, if I'm converting between those two things, I'm utilizing Avogadro's number, which tells me how many particles are in a mole. Now over here on this other side of my mole map, this is if I want to convert back and forth between grams and moles. Well, converting back and forth between grams and moles, I get to use the molar mass, which is the decimal number from the periodic table. Now that number is going to be different depending on what the element or compound is, which is why in my conversion factors I've left a question mark there. Whenever you see the question mark, that's your cue to find your periodic table and be like, okay, I need to find the decimal number. But that number represents how many grams for that substance is in every 1 mole. Also noticing the conversion factors are flipped depending on if I'm converting from grams to moles or from moles to grams. Okay, so we're going to use this mole map here using molar mass to go between grams and moles, and Avogadro's number going between moles and my particles, which once again can be atoms, ions, molecules, or formula units. Okay, so now let's get into some molar conversion practice problems, which means I am going straight down to my document camera. I am ready to go. I have a cute little picture here of my mole map. I also gave us a very much larger version, but we will not be using our mole maps for our quizzes and our tests, but I did want to have it here as a reference for, especially when we're first getting started, so we don't get like, you know, lost in all of that stuff. Okay, so this is going to also be a nice review on how to do dimensional analysis, and those are the little train track problems where we kind of did at the beginning of the year, but it's been a minute since we've done them, so we're going to do them again here today. Okay, so our first problem is how many moles are in 18 grams of sugar? Y'all, you're going to love how I do math in my class. What I teach us to do, because sometimes there are a lot of words, and words for me make me confused and scared. We in chemistry are focusing on what information is given to us, what numerical information is given to us, and what numerical information they are asking me to solve for in the problem. So they're asking me, or they've given me here, 18 grams, okay? So I'm going to circle 18 grams. Noticing I'm also circling not just the 18, but the grams behind, because that lets me know where I am starting on this conversion problem. I'm starting at grams. Awesome. Okay. Now I'm figuring out what next. What are they asking me to solve for? How many moles? I box off what unit they are asking me to solve for, okay? My moles is where they want me to end up. That means if I'm looking at my mole map, I'm starting at grams. That's where the 18 gave me, and I'm going to moles, right? So that is only one step. I do one step to get there. Now, if I'm doing a one-step conversion problem, okay, it's gonna look like this. I'm going to draw a little bit more on my thing as we're going to be getting started. Okay, my conversion factor for my one step is going to go right here. And I'm going to flip that conversion factor depending on what I have to cancel off units wise. But my given is always going to go over here. So I'm going to plop that 18.0 grams over here on the top part of the line. What's on the bottom is technically a 1. We do not write it since 1 is kind of negligible mathematically. So we're going to start with our given. It is 18.0 grams. And I'm going to go ahead and abbreviate grams for G, which is totally allowed, right? And in fact, you'll see over here in our conversion factors that we already abbreviate grams to be G. Okay, cool. I'm ready to go. I'm going to zoom in because I'm getting excited here. So if I'm going from a mass in grams to moles, mass in moles, mass in moles, I am utilizing not Avogadro's number. Nope. I'm utilizing my molar mass, okay? So I got to pick the conversion factor, and trust and believe you are not going to be measuring, okay, if I go from this way, it's going to look like this, and if I go, my picture shows this. You're going to use your units that you have written down to help you cancel out things on top and on bottom. That means that I need the orientation of my molar mass conversion factor to have the grams part down here on the bottom. And if I'm using this conversion factor to go from grams to moles, I want the mole part of my conversion factor to be on top. Okay, now all I have to do is fill in what numbers go in front of those units because this will allow me to go boom, boom, boom. Yes? Well, according to this conversion factor, it's the molar mass, which tells me there's a certain amount of grams in every 1 mole. So we always know that that's going to be per every 1 mole. Now, what I'm going to fill in here is going to be different depending on what the substance is. That will be the decimal number from the periodic table. You're like, cool, periodic table. Well, what? What am I looking for here? Who? Well, you have to read the problem a little bit more. For who? Sugar. Now, sugar's formula has got 6 carbons, 12 hydrogens, 6 oxygens. So I'm going to add up all of that with my calculator like we practiced doing last time with finding molar mass. And I'm going to write that total down here on the bottom. That will represent how many grams of sugar are in every 1 mole, which I'm now just showing as a conversion factor. Okay. So for doing my molar mass, we said there are a lot of things going on here. I got to turn on my calculator. But boom. Okay. Now, my molar mass for carbon is 12.01. 12.01. And how many carbons do I have? I have 6 of them. So I'm going to say times 6. The next element I have is hydrogen. Hydrogen. He's 1.01. 1.01. And how many hydrogens do I have? 12. So I have to multiply that by 12. Plus the next and last element I have is oxygen. And oxygen's molar mass is 16. And there are 6 oxygens in there. So I'm going to say times 6. Okay, enter. That's the molar mass of sugar. Okay, so I get to write that down here. 180.18 grams per mole. Okay, so that means I have set up this conversion problem correctly. Now the only thing I have to do is do the math that is required. So keep in mind when you're looking at your conversions, if there is a number on the bottom in your conversion factor, that means that you must divide by that number. If there is a number on top, which is not a 1, because 1 is not at all interesting or relevant or affects anything. If there's a number on top, you get to multiply on the top, okay? So numbers on the top, multiply. Numbers on the bottom, we divide by. So it looks like I'm taking 18, and then I'm dividing by 180.18. So I'm ready to go. I'm super excited. I have 18 divided by 180.18. Cool. Okay. So my calculator gives me this number, and I'm like super jazzed and excited to write down all of these numbers, except you are not going to write down all of these numbers. I have done a conversion problem that has been basically me having to multiply and divide stuff, which means sig figs are totally going to be important here. We know when we multiply and divide, the answer gets rounded to the number of sig figs as the least significant number going into it, okay? Now, here's a trick on all conversion problems. Y'all are looking at, okay, well, I got a couple of numbers here. How many sig figs you all got? If I have a number that's within a conversion factor, it is known to be infinitely significant. That just means that I do not even look at him for significant figures. The only number that I need to look at for sig figs is the number that was given to me in the problem, that 18.0. Okay, that 18.0. How many sig figs are in this number? Y'all, it is 3. And the reason why it is 3 is because trailing zeros are only significant if there is a decimal in the number, and there is a decimal in the number. So that means my 1 is significant, my 8 is significant, and my 0 is significant. So 3 sig figs for my given number means my answer also has to be rounded to 3 sig figs. Okay, so let's pop this answer up here a little bit clearer. We need to round this number to 3 sig figs. Leading zeros, I do not care if you are before, after, on top of, underneath, which is not a possibility. I don't care where they are. What I do care is that they are not significant, so I can just skip on over them, which means now that first 9 is my first significant number. So I'm going to grab the first 9, the second 9, and the third 9. If I stop there, that's my 3 sig figs. I get rid of all of the rest of that. So my answer is 0.099. And I stop, and I'm gonna, for this example, underline those 3 sig figs that I needed here, right? And so I walk away, I'm like, whew, did my problem. No, there gotta be some units here, please, right? What did you solve for? Well, I do not remember. Well, you do, because it's going to be the only thing that you did not cross off on your conversion. So we solved for moles here. So that lets us know what we have done here is that we have found that 18 grams of sugar is equal to 0.0999 moles. Okay, now in terms of the work that is required, I need to see your given and your work in your conversion factors with units. If you do not write these G's or the MOLs, I will count it so wrong. You're like, oh gosh, she's being so technical. But no, you're welcome. The reason why I need to see them and the reason why you need to write them is you are less likely to mix up which way you convert or write your conversion factors. Your units also help guide you what you need to do on the next step, okay? Because we always know when we convert, we have to cross off things on top and on bottom. So that gives me an idea of what unit I need to see on bottom for my conversion factor. Okay, so I need to see your dimensional analysis with units. I also need to see your answer with the correct number of sig figs and units. Okay, amazing. So we are ready to move on to the next one. On the back. This is still a one-step problem. Okay, it says how many well, first of all, I see a number there, and I know that number is going to get me started. Boom, 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 boom. I have 3.90 times 10 to the 28th molecules of methane, right? And they're asking me to solve for moles. So my starting unit is molecules, which is a type of particle. 2 moles is where I'm ending up. So on my mole map, I'm starting at a particle and I'm going to moles. That is one step. And I'm utilizing not molar mass this time, which means I don't even gotta look on the periodic table. I just need to know that a mole is equal to 6.02 times 10 to the 23rd particles. I'm using that for my one step. So let's see if we can map it out. Okay, so starting with, that's my given. We said it is one step, right? And that'll be my conversion factor to convert from molecule particle to moles, right? So my given is going to go up here, 3.90 times 10 to the 28th. And the abbreviation for molecule is MOLEC. Okay, so I'm just chopping off the ULES. Okay, so now with getting this started, we know we're using 1 mole is equal to 6.02 times 10 to the 23rd particles. But to figure out which way I got to flip that is I'm looking at this. I've got to cancel out molecules here with molecules down here, which is a particle, right? And to go to moles, that means I need to see moles up here, right? Because that allows me to do this. Notice I have only just written units. I have not written the numbers. In fact, when I get started with these, I tend to kind of like to fill in the units first and then go back to sub in the numbers. And this reminds you, oh, I'm using the conversion factor that relates molecule particles to moles. Oh yeah, I remember. That's 6.02 times 10 to the 23 molecules in every, how many moles? 1 mole. So I've set it up now, right? This gets me from molecules to moles. We know that if we have numbers on the bottom, we divide by. So I get my calculator out. I'm super excited. I'm ready to go. And you were like, oh, wow, whoops, these are scientific notation numbers. Yes, they are. Now, I will remind you of the wonderfulness of the E button. Everybody has on their calculator an E button, which is two capital E's right here. So to activate it, you hit the second key and then hit that button. And what the E button does is it takes the place of the times 10 to the, okay? So I'm looking at this section right here on my given, and that is going to be the E button, to where if I were typing this into my calculator, it's going to look like 3.90 E, and then whatever that exponent is. I am not doing a times. I am not doing a 10. I am not doing a little caret to say, hey, I want to make an exponent. And yes, I know I wrote 1E and you're like, well, it's got 2 E's on my calculator. Yeah, for some reason on your calculator screen, it shows up as 1E. I do not understand. I do not make the rules. Anyway, so that's how we're going to be using this and typing things in scientific notation, because it prevents us from having to put parentheses around that scientific notation number. So my calculator knows a little bit better what to do. Okay. So let's see if we can utilize that E button in this mathematical calculation. So I got 3.90 second E, and then my exponent is 28. Boom. Calculator's like, yep, we know to keep all that together. What do you got next for me? Well, next I'm going to want it to divide by that, Avogadro's number. Cool. Just make sure you use your E button. 6.02 second E, 23. And we get, boom, a big old number that I'm going to have to round to the appropriate number of sig figs. How many sig figs are in my given number? My given number, if it's a scientific notation number, cover up the times 10 to the, that is all significant for you. That is 3 sig figs. So I will even write that on this example, 3 sig figs, which means my answer, I need to round to 3 sig figs. This one's kind of a fun one. So I'm looking at this, I'm like, okay, I don't have any leading zeros here. So my first significant figure is that 6. So 6, I want that 6, and I want 3, right? I also want the 4. I also want the 7. I don't want anything else, but be careful here. You're like so excited. You're like, oh, cool, 647. Woo, walk away. Well, I have to round, but still keeping these original numbers in what place they are in, okay? I had a number here that was like 64,000 in something, right? I cannot say a number that is 64,000 in something is now, oh, yep, 647. No, I've moved that 6 a few places back. It does not need to be there, right? We need to move it back to where it goes. Well, how am I supposed to do that? Well, to keep that 6 in the 10,000s place, I need to just put 2 zeros behind it. That means that turns that 8 and that 4 there into zeros. And you're like, well, now I've got 5 sig figs. You do not. Because yes, they are ending zeros, but there's not a decimal in the number, so they are not significant. I still only have 3 sig figs, right? Oh, I almost made a mistake though. 647, I forgot. Whenever you stop on the last number that you are wanting to grab for rounding, you have to look at the number directly behind it. If that number is a 5 or a greater, you bump up the value of your last sig fig up, which I did not do. That number behind the 7 is an 8, which means that 7 gets rounded up to an 8, y'all. Oh my gosh, I almost did not catch myself on that. Okay, so yes, that's still 3 sig figs. Just do not put a decimal in the number, or else you are telling me those ending zeros are significant, and then you got a little bit of a problem. Anyway, now, what units are these? Last units that you did not cancel off or cross off is moles, and that is also conveniently what the problem was asking us to solve for. So we have done the calculation correctly, which is super duper exciting. Okay, I'm gonna do, let's see, I'm going to do a couple more of these one-step problems, except I'm going to work a little bit quicker because I know me explaining it very slowly like this is probably good to get you started, but I don't want my explanations to start dragging us down to prevent us to get to the level of just cranking out these problems to almost to the point where you don't have to think. Okay, so here we go. We are ready to go to the next one. How many grams are in 4.5 moles of barium sulfide? I have 4.5 moles is what I'm starting at. I am starting at moles in the middle of my mole map. They're asking me to solve for grams. I'm going to grams on this side of the mole map. That is a one-step conversion. So I'm ready for my one-step conversion. I'm ready to put my given here. 4.50 moles, right? Okay. To go from moles to grams, moles to grams, moles to mass, molar mass. Get your periodic table out handy. We are ready to blast off however many grams are in a mole, okay? But to figure out what part of that conversion factor goes on the bottom, I got moles here, so I need to see moles here. And this is going to take me to grams, so I'm going to put grams here, okay? Remember, our molar mass is a certain amount of grams for every 1 mole. So my moles cancel off. Now the only thinking I have to do is I gotta grab my periodic table and see, well, what is the mass in grams of 1 mole of who? Barium sulfide. Oh, I gotta write the formula for barium sulfide. Barium's group 2 with the +2 charge. Sulfide is sulfur, has a -2 charge. So my formula for barium sulfide, that ratio is a 1-to-1 ratio. So I have BAS. Okay, so 1 barium, 1 sulfur. I am ready to go. I have barium. He has a molar mass. Where are you at? Here he goes. 137.33. 137.33 plus. And then I got sulfur. He's got a molar mass of 32.07. 32.07. Just one of each of those, right? So my total molar mass of barium sulfide is 169.4, which I get to write in here, 169.40, right? Okay, yes, yeah. So this is my mentality on this, is I'm like, okay, I got to figure out where I am. Moles is in the middle. They're taking it to grams. I'm over here. I put the moles on bottom. I'm going to grams, so it goes on top. I blast a 1 in front of the mole because I know all of these equalities for these conversion factors are always per 1 mole. And then I grab my periodic table and fill out what the number is that goes in front of the grams. Okay, so remember I have numbers on the top, no numbers on the bottom, so I multiply. So I have 4.50 times 169.4, and I get 762.3. Now that number I need to round to a certain number of sig figs. I've got 3 sig figs in my given number, so I need to round my answer to 3 sig figs, right? This is a somewhat simple, easy rounder. I got 762. That's my 3 sig figs. I do not need to round that up to a 3 because the number behind him is less than a 5. But the units are the only thing that I have not canceled off. So this is grams. All right, last one. All right, how many formula units are there in 5.39 moles of silver chloride? Okay, 5.39 moles, 5.39 moles. I am starting at moles. Am I going to grams? No, I am not. I am going to my particle formula units. Moles to particles, moles to particles. That is one step, except I'm not using the molar mass. I'm using Avogadro's number, the 6.02 times 10 to the 23rd. My given goes here, 5.39 moles, right? That means I need to see mole on the bottom. And I'm going to formula units, which yet you guys, we can abbreviate as FU. Okay. Well, what numbers do I put in? Well, all of these conversion factors are for every 1 mole. And how many particles are there in a mole? How many formula units are there in a mole? 6.02 times 10 to the 23rd. We know we've written it correctly because I can cancel things out. Now I just multiply my given by Avogadro's number, which, yes, is a scientific notation number, so I'm ready for my E button to get going on here. So 5.39 times 6.02 E23. Oh, I wrote 3.02. Let's not do that. Oh my gosh, 6.02. That looks a little bit better. I was like, oh gosh, this is going to be a disaster. Hopefully it is not going to be a disaster. Okay, cool. I need to round that answer to 3 sig figs. So I've got 3.24. And you're like, amazing, bye. No, we are not. Y'all, there is some sneaky information here at the very end of this answer. E24. This number is a number that is in scientific notation because it is a giant number. That means that I have 3.24 times 10 to the what? 24. And times 10 to the 24 what? What's the units? Yes, formula units, or FU. Amazing. Okay, so these were all one-step calculations or one-step conversions, meaning I was only utilizing 1/2 of my mole map. The last half of the lesson today, we're going to do practice problems where you cruise through the entire map, meaning you'll have 2 separate conversion factors. Okay, let's get going. So first one. It says, how many formula units are in 937 grams is my starting, right? And I'm going to formula units. So I can even mentally in my brain, I'm like, I know moles is in the center of this map. Grams is on one side, and my formula units, or particles, is on the other. So I know it's going to take me 2 steps. I got to pass through moles first before I get to formula units. So I got a 2-step problem right here, right now. So I got yeah. So I have my first conversion factor is going to go there, and my second conversion factor is going to go here. My given, as usual, we're going to start off right here. So I have 937 grams, which means I need to see grams here. And this first step we know is my stopping place at moles. So this is going to take us to moles. So I'm like, okay, well, what numbers do I fill in? Well, whenever you write moles, it's always 1, right? Whenever I write grams, I kind of think for a little bit. Grams, periodic table. You're like, okay, got to find the molar mass, Who am I finding the molar mass for? Oh, I need to look at what the thing is. Calcium phosphate. Okay, got to write the formula for calcium phosphate so I know how many is in that entire stuff, right? How many is in that entire stuff? So calcium's got a +2 charge. Polyatomic ion phosphate has a -3 charge. So the ratio of ions that I need for calcium phosphate are Ca3. And then PO4, I need 2 of those phosphates. Okay, so here we go. We're ready to go here. So calcium's molar mass, I feel like we cannot see. There we go, I'll just do this. Calcium's molar mass is 40.08. And I have 3 of them, so times 3. Plus phosphorus's molar mass is 30.97. And I have 2, because that 2 gets distributed to the inside, times 2. Plus, and oxygen's molar mass is 16. And how many oxygens do I have? 2 times 4 is 8. Okay, so the total molar mass of calcium phosphate is 310.18 grams per mole. So I can say there are 310.18 grams per every 1 mole. So this step worked great. This was us going from grams to moles. We are now in the middle of the mole map, but we are not stopping at moles. The problem wanted to take us to formula units, so we are going the next step using Avogadro's number, which says for every certain amount of moles is equal to a certain amount of particles or formula units. Specifically, 1 mole is equal to 6.02 times 10 to the 23rd. Okay, and this conversion, when I get ready to type everything in my calculator, yes, it will cancel out moles, which means I will allow to now convert from moles to my formula units. Okay, amazing. So I got some fun things going on here. I've got something on the top that I need to multiply my given by. I also have something on the bottom that I need to divide it by. Okay, so I'm ready to go. I go 937 times Avogadro's number. I'm just going to tackle the stuff on the top, multiply whatever's on the top. So 6.02 E23, right? And then I'm going to divide by that molar mass that I had on the bottom here. So all of that divided by 310.1, what is it, 8. Cool. All right, don't be freaked out. We notice that we have a number that's in scientific notation, so we're going to make sure we write it at times 10 to the 24th. But we've got to count sig figs. My given has 3 sig figs, so I need to round this to 3 sig figs. I feel like all of the ones we've done so far are 3 sig figs. No matter. Okay, so I go 1 point. In fact, I'm going to write it. 1.8. Not 8.1, but 8.2, because the guy behind the 1 there is an 8, which means I got to round up. So 1.82. And then I've got scientific notation times 10 to the 24th. And my units are FU, formula units. Cool. So this is our first 2-step conversion that we actually did here, okay? So I have space for 1 conversion factor, which was my molar mass. That took me from grams to moles, so grams to moles. And then I had my next conversion factor, which was Avogadro's number, which took me from moles to those formula units. Okay, let's do the next one. All right, how many grams are in 3.21 times 10 to the 24th formula units? So I've got 3.21 times 10 to the 24th. I'm starting at formula units, my particle. They're asking me to go to grams, so particles to grams. All the way through the mole map, I got to stop 3 moles though. First utilizing Avogadro's number and then using molar mass. Okay, so 2-step problem. My given. Here's my first conversion factor and here's my second conversion factor. Okay, So my given is 3.21 times 10 to the 24 FU, which means I need to see FU down here. And I'm stopping 3 moles. This first step takes me to the middle of the mole map, 2 moles. So you're looking at this, and you're like, what number's going here? Well, it's always a 1 in front of mole. Well, 1 mole is equal to how many formula units? A formula unit is a particle. 6.02 times 10 to the 23rd. Formula units. Cool, cool, cool. Yeah, now I'm at moles. Okay, but I got to take it to grams. So I need to see moles on the bottom. Whenever I write moles, I get a 1. That means I also need to see grams on the top. You're like, where do I get grams? Grams, 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 molar mass, right? So that means I'm going to have to fill in what the molar mass is of, potassium hydroxide. Potassium is an ionic, this is an ionic compound with potassium a +1. Hydroxide polyatomic is a -1. So my formula for potassium hydroxide is KOH. All right. Which means on my periodic table, I got to add 1 potassium, whose potassium's molar mass is 39.10, and 1 oxygen, whose molar mass is 16, and 1 hydrogen, whose molar mass is 1.01. Okay, so the total molar mass for potassium hydroxide is 56.11 grams per every 1 mole. Okay, so now I'm ready to figure out what the answer is. So I've got 3.21 E24. I'm multiplying everything on the top together first, times 56.11. So that's all my stuff on the top. So now I'm ready to divide that by my stuff that's on the bottom that is not a 1. So 6.02 E23. All right, let's see. Cool. Okay, so I got 299.1999999. Okay, well, how many sig figs am I rounding this answer to? Looks like we're keeping consistent with what we've had. There are 3 sig figs in this number, so I need to grab this and be like, okay, 3 sig figs, 3 sig figs. This one hopefully is not too tricky. I want the 2, I want the 9, and I want that last 9 as is, not having to round him up because the one behind him is a very small number. But the units do matter. I solved for grams here. So this is 299 grams. Okay. So if you're noticing I'm working a little bit faster, hopefully modeling how I'm allowing the units to kind of walk me through here. I've also noticed that whenever I write mole in a conversion factor, the number going in front of it is a 1. I'm also noticing that whenever I write gram as a conversion factor, that's where I gotta fill in my blank with something from the periodic table, that molar mass. Whenever I write a particle, whether it's going to be an atom, an ion, a molecule, or a formula unit, I'm writing Avogadro's number. Okay, so you let the units walk you through and then you put in the numbers that relate to those units in your conversion factors. That's my mentality as we get cruising through these molar conversions. All right, we got 2 more examples and then we're gonna call it a day. I've got how many formula units are in 2.00 grams of aluminum fluoride? Okay, I'm starting at grams. And now I'm going to formula units, a particle. That is a 2-step going from grams to moles and then to formula units, a 2-step conversion, right? My given goes here, 2.00 grams. I see grams. I need grams down here. This is going to take me 2 moles. Filling in, we know this is a 1. And we know molar mass. And in fact, I'm going to come back and fill in that molar mass. I want to crank on through and make sure I can blast out this second conversion factor. So the second conversion factor is going to take me from moles to my formula units, which means I need moles down here. And I'm going to formula units, which means I need formula units on top. Boom, boom. That number has to be a 1 in front of moles. The number in front of a type of a particle is always 6.02 times 10 to the 23rd. So I can fill that in super fast. Now I can go back here and say, okay, brain, reset. Now I got to find a molar mass of who? Aluminum fluoride. Oh my gosh, writing a formula again for an ionic compound. Aluminum's got a +3 charge, and fluoride is fluorine with a -1 charge. So aluminum fluoride is AlF3. So for molar masses for aluminum fluoride, I have 1 aluminum. So aluminum, his molar mass is 26.98. So I have 26.98. There's only 1 aluminum. And then I've got fluorine. So fluorine is up next. Where's fluorine? He's right here. He's got a molar mass of 19. And there are 3 fluorines times 3. So the molar mass of aluminum fluoride is 83.98. 83.98, of course, grams per mole. Okay, so now we're ready to go. Everything of cancels off, looks good. Multiply 2 times Avogadro's number, and then divide it by 83.98. So I've got 2.00. You don't have to write 0.00, but I'm doing it just randomly because why not? And we're multiplying by Avogadro's number times 6.02 E23, and then dividing by that 83.98. 83.98. Okay, let's see what we get here. Ooh, okay, so we get 140 or 1.43 blah, 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 times 10 to the 22nd. Okay, but how many of these original numbers are we going to call significant depending on what the number is in the problem that they gave us? This 2.00 is 3 sig figs. Those ending zeros are significant because of the decimal in the number. So I'm going to want 3 sig figs for my answer. So I got 1.43. And that's all I'm going to take, but I do need the times 10 to the 22nd. And the units are formula units, so FU. Wonderful. All right, last problem. We're doing so great, you guys. How many molecules are in 654.5 grams of sulfur hexafluoride? Okay, so my given is in grams. I'm starting here. And they're taking me to molecules. Well, a molecule is a type of particle. So I'm going from grams to moles to molecules. It is a 2-step conversion factor, right? Or 2-step conversion problem with 2 conversion factors. My given of 654.5 grams means I need grams down here on the bottom. And we're going to moles from this process. So I need to be able to do that. I also need to know that I'm going from moles to molecules. So my second conversion factor's units need to look like this. Molecule, right? So now I just can fill in the numbers. We know 1 is always in front of the moles. We also immediately know that molecules is a particle where I have Avogadro's number, 6.02 times 10 to the 23rd. The only really thinking I have to do is that number that goes in front of the grams, the molar mass. That's my periodic table, and it depends on what the chemical formula is of sulfur hexafluoride. Sulfur is a nonmetal. Fluorine is also a nonmetal. So I'm looking at a covalent molecule, which it says molecules here in the problem. But I can tell how many of each I have based on the prefixes in front. So I have only 1 sulfur. And I have hexa is 6. I have 6 fluorines. So for my molar mass, I am adding up the mass of just 1 sulfur. And 1 sulfur is 32.07. And then I have 6 fluorines. Well, 1 fluorine is 19. And I have 6 of them, so I multiply that by 6. So the molar mass of sulfur hexafluoride is 146.07. So I go 146.07. All right, so looking at this, I'll solve it here in a second, but I want you guys to see every time I have moles, it's a 1. Every time I have a particle, whether it's a molecule or it's a formula unit, or it could be an atom or an ion, one of those 4 things that we know to be particles in chemistry, I have Avogadro's number written in front. The grams is the only sneaky thing. That's molar mass. Okay, so I type it in my calculator. So I go 6.54, or 654.5 times 6.02 E23, and then divided by 146.07. Looks right, I think, hopefully. Okay, amazing. So I got some scientific notation number here, but ooh, it's something that's not 3 sig figs, you guys. It's 4 sig figs in my given. So my answer needs to be rounded to 4 sig figs, which means I've got 2.69. Do I need to round that 7 up? I do not. So 7 and then times 10 to the 23rd. What are the units for my final answer? It's molecules. And that is it, you guys. We've done some molar conversions. So looking at what we've done here, is my one-step problems. They are either starting at moles and going to my grams or particles, or they're starting at grams or particles and going to moles, okay? My two-step problems, they're having me work all the way through the mole map. Now, I know it's a little bit sneaky. I love giving y'all the mole map, but I almost kind of like don't love it because then y'all use this as like your emotional support, like security blanket, and think you are not possibly able to solve these problems without it. I did put it in here to kind of get us started, but I want for you guys to be able to visualize this mole map in your brain. You're like, oh gosh, she's having me memorize. But not even be able to have to visualize it, just allow, like we had here, our units to guide us through where we need to go. And then you're not having to memorize anything. You just know you're walking through a little journey here on these wonderful little train tracks through Mole Town or whatever, to be able to convert. Now that we know about molar mass and Avogadro's number, we can use those as conversion factors to allow us to convert from one of these units to another. So this is fun, and enjoy all of the practice that I've given on you guys. The practice is definitely going to reinforce this concept and make you guys all chemistry superstars.